So let's start off with I would say the harder part of it is when you're given some function, like let's say if I told you f of prime equals, now I'm giving you the prime here just because I can't make up one that does all the layers. So let's say if we already did the work. So f prime is x plus 3, x minus 2 squared, x minus 1. I guess we'll put an x in front too. So let's say you prime something and resulted in that kind of factored form. I would ask you, what is the critical points? What are the possible, or I should say this. The question will say something along the lines of, what are the critical points that could possibly be a extrema, aka a local max or a local min? And follow up with, tell me which ones are local max and local min, and show me where they increase and decrease. Now you could do all that with the number line. So I'm going to make a number line from here to here. So before I make the number line, I need to figure out what my points will be. 0, -3, +2, +1. So I'm going to make a number line, -3, 0, 1, 2, and so on and so forth. From here, we have different sectors. I'll just call them, to help us name it a little better so it makes sense when I'm talking about it, A to E. All right, so the first thing I'm going to do is take a number from section A, let's say -4. And what I do is I plug in -4 for everything here of all the x's and see what terms or values come about. Again, I don't actually care about the number, I just care about the sign. So if I get a negative, a positive, and a negative, overall, negative, positive, negative, all multiplied is one big negative, which means in this section, it is going downwards. Over here, I'll plug in something between -3 and -0, so -1. So I'm going to plug in a -1 here. So that's going to cause a negative, a positive, and a negative. Overall, that's going to be positive, so that's going up. From 0 to 1, I'm going to put 0.5. So from 0.5, I'm going to get a positive, negative. So overall negative is going downwards.
How is 0.5 minus 2 positive?
Squared.
Oh, I didn't see that.
Then let's do 1 to 2, so 1.5. So this is going to be positive, x minus 1 is positive. So overall positive, so it's going up here. And then it's going to plug in something bigger than 2. Let's plug in 3. Positive. So it's still ascending this section. So in this situation, what is the maxes and what are the mins? In this case, local mins. This is mins. So the mins that occur are at x equals when they're going down and then up. So x equals -3, x equals 1. The max that are occurring is when it's going up and then goes down. So at 0, and that's it actually. Because 2 is up and then flattens and then up again. That is neither max nor min. So those are listing the max or mins. And then in the instructions I do say, can you show me where they're increasing and decreasing? With the number line, it's increasing or decreasing. If this was, I think last year I showed you this when we talk about increasing and decreasing, or zones, we might say from here, soft bracket, negative infinity to -3. Does this feel familiar?
Yeah.
Soft bracket, this would be 0 to 1.
Wait, do we need to do this?
No. I'm saying if you have the number line, you already show me where it's decreasing.
Okay, great.
Okay? You already show me where it's decreasing. and increasing. If you don't draw the number line, or you do some other method, or it's not clear to me, if you're sloppy handwriting, write it like this, okay?
Yeah, I'm not gonna do that.
Are we learning more material that's gonna be on the test for tomorrow's or?
We're not learning new things. Because tomorrow will be the last day, so we'll review stuff.
I'm scared.
All right, let's do the next version. Again, I don't have one that's like, I can't think of one that will work out, so I'm just gonna give you as if we already did all the work. Remember, usually you factor to this point, so I'm giving you as already factored, already did the stuff in the beginning. So let's say x squared, x plus 2, x minus 3. This is the f double prime. So in this part, I would definitely ask you, tell me where the inflection points are, and show me where it's increasing, or is concave up or concave down. The method that we do, or the work we do, is exactly the same as the previous one, where the answer here is 0, -2, and a positive 3. So -2, 0, 3. I labeled the section so it's easier to talk about. Then you take numbers and plug them in. Let's say -3. If I plug that in, I'm going to get a positive number, a negative number, and a negative number. So overall positive, which means it's concave up in this section. Over here, you have -2 to 0, so like -1. So that's going to be positive, positive, negative. So that's concave down.
Wait, what? Why?
Overall, it's negative, so it's concave down.
Why is that one overall negative and the first one is overall positive?
Double negative becomes positive. So
Oh.
positive times positive. This one over here, 0 to 3, let's plug in a 1.
Wait, what?
Positive, positive, negative. Overall negative, so it's still concave down. And then positive, positive, positive. This is overall positive, concave up. Plug in a 4 or something. So if I ask you what are the inflection points, they're at -2
Inflection points.
and
You
at
can
3.
write the interval if they're already showing you the graph.
You do not need to write the interval, you just show me the graph.
Okay, cool. Wait, what's the -2, 3?
These are the inflection points.
Inflection.
So that's where it like starts to curve.
That's when the curving changes from increasing to decreasing, or in this case, decreasing to increasing. As the slope gets more and more positive as you move
It's
forward.
having super inflection.
Why is 0 not an inflection point?
Because what's happening on the left or the right is 0.
Okay.
It didn't change, that's the problem.
Wait, what does inflection point mean again?
It means it's the concavity has changed. It's the point where the concavity has changed.
So like this.
So if it's
It
going
goes
down
like
and
this.
back
This
up,
is
that
an
counts
inflection
as
point right here.
inflection?
No.
Where it changed,
Yeah.
yeah.
Like,
When the
it's like
slope
curve.
has, so it's the slope of the slope. Which means from here to here, what's occurring is that your slope is getting more positive, more positive, more positive, more positive. Then there's a moment where it stops doing that and starts getting more negative, more negative, more negative, more negative. Even if it is positive at this moment, it's going to become negative eventually. Or until it hits the next inflection point. No. Oh. This one, I forgot, I was going to give you a simple one that I just give you basically a graph. I'm going to give you one that, well, you just look at it. So let's put it here. I guess you can know.
Beautiful.
This is, all right, let me use a different color. 1, 2, 3, 4. 1, 2,
Oh, also,
3,
I have to add some
4,
things
5,
to the notes stuff.
6. Okay,
I don't care.
I just made it work. All right.
Okay.
So in this one, I would ask you, where are the local max and mins? What are the absolute max and mins? What is the domain of this? And what is the range of this? If I ask for the range, I gotta make sure I put this down.
So the range is up, down.
Yeah, I have to put that there if I say for range. So, first question I would ask, where are the local max or min? I would probably just say local extrema. Just know that's local max and min.
-4 is a local max.
Well, we're gonna list all. I guess I would probably ask you to list them. So tell me the maxes. Go ahead.
-4 and 1, 2, 3, 4, and 5.
And 5. Is there any other ones?
No, only an absolute.
Oh my God, what's wrong
An
with
absolute
this?
max is still a local max. It's also max locally.
So also
Also 0. Okay. So the mins is going to be
-2.
3 and 6. I will ask for the absolute. We already kind of answered that.
So
But the absolute max,
absolute max is 0 and absolute min is -2.
the absolute max is at 0. The actual value of it though is 5. So just remember, if I ask for the where it is, it's at 0. If I ask what the value is, it's at 5. That doesn't matter. I'm going to ask where
What do
it
you
is.
mean, what I've done?
Ask this.
I'm just going to ask where it is. I don't.
What
I
do you
don't
mean
want-
when you say
Don't ever say that other thing again.
Yeah.
I don't, that's why I'm asking.
If I ask where it is, that's x equals 0.
Right.
If I ask what is the absolute max of this function,
Scary thing that interesting.
what it is actually 5. What it produces is 5. Where it is
Are you
actually.
asking now to test?
No, I'll just ask you what it is. I shouldn't even mention that. Guys, please stop talking. So then, the absolute min is the lowest point of this whole thing, which is at -2.
Domain.
Okay. The main, you need to make sure you use your brackets here. Since I actually start with a closed circle over here, these are all closed circles in this case. Remember, you have to use a hard bracket. So a hard bracket from -4 all the way to 6.
Are you gonna give us an open circle just to throw us out?
Maybe.
Definitely.
Range
Definitely will.
is what's the lowest y value to the highest y value. So
-2,
-2,
1, 2, 3, 5.
5.
It's the min to the max.
-2, yeah. To the
You're
5.
mid to the max. Me too.
You know, that's not good.
Is there anything else from that section?
Oh yeah, it is bad.
Flip it.
You're max to the mid.
Thanks.
Oh, one more thing from this section. Guess kind of continuation from the f of x thing. Let's say if I told you a function, and you got like this, let's say x plus 2. But I told you the domain was from, let's say, -3 to -1.
Oh, just do what you did before, but then on the number line, add those numbers also.
So the same thing, you're going to find the solutions, 0, -2. These are technically possible critical points. But when I make my number line, I'm going to have hard stops at the ends because I have endpoints of my function. I have endpoints of my number line. So in this case, -3, -1. In this scenario, oh wait, I could fit -2. But if it is a situation, if it couldn't fit, it does not show up on your number line at all. It cannot be a max or min, okay?
Are you gonna do that, Dustin? I'm totally gonna
Why is -2 there?
I was planning to do it right now, but I forgot that you had to switch the sign actually. So.
Wait, why is what?
Okay, wait. Oh, I did do it correctly. Wait a second.
You did it so weird.
Yeah, my fault. So -3, -2, -1. 0 in this case, even though it would be a critical point in a normal situation, does not show up in the number line. And thus I do not draw in my number line, and thus it does not become a min or max no matter what.
Sweet.
Okay? So if your domain cuts
How
it
do you
off,
know
you cannot
that?
include it.
How do I?
Because
Oh, because of the brackets on the top.
Yes.
Oh.
And if I gave an open circle like this,
Negative box.
you would have an open
And
circle
either way,
here.
the 0 would not have been before, in between -3 and -2. That's where you put it.
Yeah, that's what I mean. I made a mistake before. Because I thought I cut off the -2. Alright. Next thing.
You're not gonna answer it?
Oh, the hospital rule.
I hate that.
Not that bad. So the limit, or
Go blue.
oh, actually, yeah, it's a limit. Limit is x approaches 0.
Yeah,
I mean, right now, I don't know if he's your
he
friend.
is.
Yeah, he is.
Yeah, Ben.
Him.
I need to look up
There is
a rule.
Why I said
Is
listen
it just
to
that the derivative of something is the same as the something?
You're right, but I want to make sure I make
Of the
a question that
function.
makes sense.
Knows what I'm trying to say.
What time's the play?
Today, yeah, 7.
What about tomorrow?
Tomorrow, 11:30.
Period.
It's
No,
three and cos.
There's no float tomorrow?
It's one,
Your
two,
eyelash?
four, five,
Ariella?
Is there floats?
She's
Sorry.
Oh, okay.
There's no three and there's no cos.
That's so annoying.
It's like one,
Give me
two,
one of the
four,
forces
five,
on the
five.
left.
Yeah.
Oh, okay.
And then lunch. Wait, so are we missing one? Us, cause strike and then we can. So we're having lunch at like 2. And
I can take the five.
All right.
Strike is like taking down all the stuff you.
So Lahaspa rule.
Yeah, literally.
It asks us
Cleaning up.
the derivative of a limit is the same as the actual limit. Now the thing is, if I plug in 0 here, what occurs?
Undefined.
I get sine is 0, which is
It doesn't-
y value is 0, over 0, which is undefined, so that's not helpful. So I need to figure out how to reduce this. I can't simplify it like before when we did with polynomials where I can cancel things on top and bottom. So in this case, I'm going to derive it. So I'm going to derive this. So I'm going to get, what's the derivative of sine again?
Negative cosine.
No, it's just cosine. So cosine x over, what's the derivative of the bottom?
3x squared.
Oh wait, you're right.
I'm like, what?
For some reason I did 2x third, my bad. So cosine x over 3x squared. Now if I plug in 0 now, what's the problem?
Still doesn't.
Still 0 over 0, so not helpful. So I gotta do it again. Derivative of cosine.
Negative sine x.
Negative sine x over
6x.
6x. Plug in a 0. So I have the same problem. Next one. Negative cosine x over 6. In this case, if I plug in a 0 into cosine, 0 cosine is your x value, so that's a 1. So it's equals negative 1 over 6.
Oh, we're gonna need to know that negative cos x equals negative.
You gotta at least know the 90 degrees of some sort. Actually, you don't even know because there's always limit x equals
But if
0.
I just leave my answer as negative cos x over 6, is that wrong?
Yes, because I asked what the limit is at 0.
Oh, so I plug in
So we have
0
to,
and know that
we have to
cos 0 is.
remember the,
One, yes.
the circle.
You will not need to remember the circle. The only thing you need to know is at 0 degrees. That'll be for the y value, which is sine, that's 0. And for the x value, which is the cosine, is 1. Because I'm going to ask you to plug in 0.
Like,
So cos x equals 1 and sin x equals 0?
Yes. Let's see if I can find another one that works.
But we also need to know that cos x is negative sin x.
Say that one more time.
That cos x derived is negative sin x.
Cos x derived. You need to know the derivatives of sines and cosines, yes.
are you gonna, what about like,
Triple
are you gonna say a
derivative?
secant or something, or like?
Probably not in this test.
Triple
So
divide.
just the original 3,
Just the OGs.
not even tangent.
The OGs.
The OGs.
Oh, jeez.
We'll do this one. Alright.
What happened to this?
I'm looking for another the hospital.
You want me to try again?
No, I'm looking at this worksheet. This one, I want to look for ones that definitely could work for us.
I wonder why.
They're like ones you gave us when you first taught it, like
Sure, give me what I gave you.
limit as x is approaching infinity, ex over x squared.
Okay, infinity ex over x squared. Okay, if you plug in infinity, you're gonna get infinity over infinity. The problem with that is I don't know how distant each infinity is. So does that correlate to 1 over 1? Does that correlate to 8 over 3? I don't know. So I need to reduce this to in order to do that. This is not an answer. So we derive the top and bottom. Luckily, the derivative of e to the x is,
E to x.
E to the x.
and then that's 2x. I should write arrow because it's not equal to each other.
You're gonna derive again.
Then I'm going to force it to be derived again because the bottom is still infinity over infinity. E to the x over 2,
So that's
The-
infinity over 2, which is infinity.
which is now just infinity, yes.
Can we know that from the beginning?
If you recognize it, maybe, but
Are you gonna
You
give us?
you see e to the x at the top? You see what it is?
no, because I can put something bigger on the bottom that causes it to be 0.
What's
Infinity
bigger
over
than
infinity minus 1.
I could put 2 to the x on the bottom.
No.
Something like that.
It's so great. Every time we bring this
Yeah,
up,
Okay,
Yeah,
even
right,
then,
like-
then the next you gave us,
uh,
well,
The next one was a sine one, imagine. Or a
no,
trigonometry one.
it,
No?
well, you gave us tan x minus x over x cubed. You're gonna give that to us?
What was it?
Tan x minus x over x cubed.
That's a cool one. Limit is what? X approaches 0?
Yeah.
Tan x minus x over
X cubed.
x cubed. I need to figure out more that there's just the bottom is like 0, but whatever. I'll figure those out. I'll put them later. So tan x minus x over x cubed. In this case, we can't plug in 0 because tan of 0 is 0. Negative 0 minus 0 over 0 is 0, 0. That's not okay. So let's derive. What's the derivative of tan?
Negative cotangent?
No.
Yeah, get cosecant tangent. Cotangent, something like that.
Secant squared.
Thank you.
Never
Secant squared.
mind, I'm so off.
X. Now what's the derivative of
One,
x over here?
1.
Minus 1
I knew that.
over 3x squared.
Oh, but that's an identity.
That is identity.
It's
What's
cosine.
identity?
Tan x squared.
So
Tan
close.
squared. Cosine goes with cosecant. Secant goes with tan. So then it's tan squared over 3x squared. Now we have to rewrite that again.
6x on the bottom.
6x on the bottom. This tan squared is going to be 2 tan and the derivative of tan x, which is secant x.
Nah.
Because it's chain rule. Now tan times secant. Tangent is what again? Sine over cosine or cosine over sine?
Sine over cosine.
Good. What is secant actually?
Cosine over tangent, I would say.
Not even, just 1 over cosine.
Ah.
Does that help us?
It's not right.
Or we could just do a product rule.
No, it's, I mean, here.
What did I do next?
On the homework, it's, when it's this step, secant is squared.
Secant squared?
It's 2 tan x secant squared x over 6x.
2 tan x secant squared. Oh, because the derivative is secant squared. But that still doesn't, that causes me a problem still.
And then from that, you get the top to just secant squared.
I got the top to just secant squared.
That's what I wrote down in the homework. I feel like we just don't do this one.
Yeah, we won't do this one. I'll figure out the exact level, because they could get, of course, if you notice this, because you're deriving, especially multiple times, especially if it's a trig, it gets wild. So I'll try to curate it to be.
So let me not have one like that.
I'll find the worksheet, practice worksheet for you guys,
Yeah.
and
The last
I'll
one.
tell you which ones are the level that you should.
So like ln x over cube root of x.
Oh, that's nice one. So ln x over the cube root of x as the limit approaches
Infinity.
infinity. So limit
Infinity.
as x approaches infinity. Now it's infinity over infinity. Again, the issue with that is I don't know if it's 1 over 1, 10 over 10, or 10 over 3, or something like that. I don't know what the actual rate is. So I gotta reduce this. So the limit on top is the derivative of the limit x on top is 1 over x all over. The derivative of that is negative 1/3 x.
No, positive 1/3 x and then negative 2.
Positive 1/3, you're right. So x to 2, negative 2. So then, we plug in infinity. Is there a problem with that now? Oh, it doesn't matter because now, let's say I do rewrite this. So it's 1 over 3x to the 1.
Wait, how'd you get the 1 over 3?
You change this to x to 1/3,
Oh, God.
bring it to the 4. So I'm gonna rewrite this. X to the 1 times x to the negative 2/3 is x to the 1/3. That's exponent rules.
It gets wild.
But this here, we're actually okay, because at this point, if I put infinity on the bottom,
Wait,
I
can
get-
you go over that last step one more time?
Oh,
sure,
yeah.
I did that all at once. I
This
guess.
is just 1 over infinity.
Yes, which is
0.001. It's approaching 0.
is approaching 0. So we just say 0 because it does approach 0. So I'm going to rewrite this as 1 over x times 1 over 3 x to the negative 2/3. This part is for here, and this part is over here. So then, if you rewrite that combined, you should get back to here. And then we're okay with that because
Are you? Oh, are you just moving the x down?
I'm moving the x down and then moving it around so it combines.
How is that allowed?
It's the division of a division, so I could just put that down. So
But if it was like adding or subtracting on the bottom, you wouldn't be allowed to. You would have to multiply the whole thing out.
you would actually have to factor or something
Yeah.
like that. Or FOIL, I should say. The distribute. So here we're going to get 1 over infinity when we plug in infinity, which is okay, because that answer is 0. We box it off.
When we did it, we got 3 over infinity, so something different, but I guess the end answer is
It's still 0.
He doesn't want to do it all over
yeah,
again.
something.
3 over infinity?
Yeah.
I guess I have to flip this up. I don't know why would I do that. Oh, it's division of a division, so that should be a multiplication.
That's crazy.
Yeah, that's what it
Fair enough. You get the final answer. I don't care. All right, that was the hospital rule, and then there was one more thing we learned.
is. That's there.
Yeah, hospital.
And the last thing we learned is
Word problem.
word problem. Yeah.
Whatever.
Oh, actually,
Still
I
have a
honestly
test.
really like those. For
Yeah,
this.
real stuff. Like your show.
Maximization or optimization problems. So
Oh, maximizer.
okay, so that
Uh,
the sum of two numbers is 120. What is the maximum product of the two numbers? Yep. Alright, so the sum of two numbers is 120. What is the maximum product of two numbers? So, in this case, we have to make sure that we have to make sure in this situation, in this situation, we want to set up our equation. So the first equation I need to set up is the sum, so I know that's addition, is 120. So x plus y equals 120. The second thing I need to know is the maximized product of the two numbers. So x times y equals some product. I'll capitalize capital P for that. So x plus y equals 120. X times y equals the product.
X equals 120 minus y.
Good. So I want to solve it so I can set it up as one variable. So y equals 120 minus x.
I like switching it.
It's okay. You'll see the same number.
It
anyway.
does the same thing.
So then I'm going to rewrite this y as 120 minus x equals p. Distribute the x. 120x minus x squared equals p. Then we're going to derive. So when we derive, I'm going to reduce this to 120. This is going to become 2x. And then this p value is going to be 0. Technically it's dp over dx, but I know I'm looking for a maximum, so I set it to equal 0. All right? In that case, I want to see where x is. X equals 2x on both sides, divided by 120. No, wait, no. I'm sorry, minus 120, so x is 60. So then, if x is 60, I could plug x is 60 over here. So y ends up being also 60. Says I'm looking for the maximized product. I want the actual answer. So 60 times 60. And that's going to equal 3600.
And we said that we get full
This one
credit
actually
if
makes
we figure it out
I
without
can explain
using
this
the math, right?
Nothing else.
What?
What?
Did I say that?
Did you say?
I don't think I said that. No,
What if you believe you said?
no because if in order to avoid that, I would need to make more complicated questions. All right, you just show you work on a simple one that happens to be the same number both. Otherwise, I will purposely make it harder.
Fine.
What's up?
How do you know it's x, y equals p?
X, Y equals P?
Of two numbers.
Yes. Product is multiplication.
Oh, it's this product. Got it.
And then one more, something like a cardboard box. Oh no, we'll do a fence.
Can we get more of the first one? I like those.
Like a fence on the river.
No.
Yeah.
It's not like a song.
So you don't, there's a band on it.
It sounds like a good idea for a song. To talk about how you're a fence on the river, just
240
it's
feet
like
of
letting all the
fence
world happen to you,
on-
but all you're doing is moving along with the currents. That's
That's
beautiful.
not a fence.
Write it.
It's the river itself.
Yeah.
It's kind of beautiful.
You should write it.
I should actually.
To the river.
Yeah.
It's gonna not a real word.
You can put at him. It's going to doesn't matter. Like,
Wait, hang on. It's gonna not a real word.
What is the most area?
It's crazy.
What's the most area the fence can contain?
don't go and go to this thing.
Alright.
Don't pressure me.
All right. For this one, a farmer has 250 feet of fence. One side of the area is going to be next to the river, aka I don't need to put a fence next to the river. What is the most area the fence could cover? So if you have a river like here, you could have some box like this of fencing. If we call this width, and this is length. So the first thing I can set up is the fence. I know the fence is going to be 2 widths and a length. So I'm going to do 2W plus L is going to equal my fence, 240. Also want to know the area of the thing. What's the area of my fence?
L times W.
It's just L times W, nothing tricky with that.
I have a question.
Yes.
Length times W is always the area.
If I said, I should have said it's a rectangular fence, but yes.
Okay, yeah.
I have to point that out. I'll point that on the actual problem.
Because I was gonna say, like, what if you have to like divide by like 1 L?
Because the weird part would be the maximized way, I think it'd be a semicircle, but I don't know if that's true actually. I have to
L
test it.
equals 240 minus 2W.
So we're gonna solve for L. So L is gonna be by itself, just because I don't wanna deal with
I
the 2.
understand. I agree.
So L equals 240 minus 2W, which means now I can replace the L with 240 minus 2W. Next to W equals A. Distribute that W, 240W minus 2W squared equals A. From there,
Derive.
we're going to derive first. So 240 minus 4W equals the area. The derivative area I care about is 0. Solve for W. A little bit of algebra will show you that's going to be 60. If that's 60, I can take that 60 and plug it into here, which means my L is going to be 120. My L is going to be 120.
Multiply them.
So I wanted to figure out what the most area could be. I found what the cause is the most area. So 60 times 120, 7200. All right, if I think of more problems that will be on your test, I'll tell you tomorrow, okay?
I'm really scared. Why 7,200?
120 times 60.
Wait, so what are you? Oh, yeah, like
I basically you plug it back into this equation. So whatever equation you made here, you're going to plug it back in at that. Since I'm asking for the most area.
Can you record bars on YouTube?
Sure.
What time is the play tomorrow? 11:30.
You're not.
So I can say third or no?